I'll start with the first session. Now I'll introduce the first speaker of the session, Mr. Dhananjay Khon. He comes with 20 plus years of experience in handling key accounts, developing channel partners, and business development. He has worked with MNCs like Secure Meters, Lab India, Belden, and Leone Cables. He heads India business development at Instron Technologies and interacts with customers to understand uh, the needs to offer them innovative solutions. I request Dhananjay to take us all through the background of the organization and highlight why users should listen to these experts. Over to you, Dhananjay.
Thanks, Milind, for briefing about today's topic. Good morning, everyone. Thank you for joining us today. We will be taking you through our company profiles, strengths, and reach experience in the industry. Let us start by looking at who we are. We are 10-year trusted company in industry and remarkable journey with the various experiences. Instron Technologies having a global presence with the installation in more than 6 different locations worldwide. Our organizational culture is not just a tagline, it's the fabric that binds us together. Our leadership is the backbone which fuels our innovative approach, empowers our people, creates an environment where everyone grows together. Innovation is in our DNA. We encourage our team to think outside the box, to challenge situations and come out of the integrated solution. This spirit of innovation sets us apart in a rapidly changing market. Our mission is to foster innovation and sustainability across the manufacturing and R&D sectors. We provide comprehensive solutions, forward-thinking solutions, and elevate efficiency and set new standards for environmental responsibilities across the industry. Our motto, let us grow together, reflects our commitment towards collaboration, working, and progress. Now let's get closer look at our company through our corporate video.
We at Instron Technologies deliver our products and solutions for domestic and international customers, for manufacturing industry, for process industry, and also research laboratories. And we could do this because of our in-house cross-domain expertise, reach experience, and dynamic team. Hello, I'm Milind Saindame.
Hi, I'm Rahul Gokhale. Hi, my name is Rahul Shirude.
I have 19 plus years of experience into research, new product development, and Internet of Things.
I have more than 2 decades of experience in process engineering, automation solutions, and new product development. With me, I bring 13 years of experience in automation and IoT new product development.
Instron was incorporated as a proprietor firm in 2013 and Instron Technologies LLP was formed in 2016. Based out of Industrial Hub of Pune, Maharashtra. We have served 200 plus reputed clientele and now we have incorporated Instron Technologies Inc. in Canada to serve the North American market. This makes us MNC with Indian origin.
Instron Technologies offers products and solutions into 3 verticals: process plants, digital factory solutions, and test bench systems.
In process plants, we help customers right from conceptualization to detailed engineering and also complete plant supply and installation. In digital factory solutions, we help customers monitor their critical parameters on the go by offering systems right from sensors, communication with existing PLCs, and then giving authenticate data to empower the decision makers. And in test bench systems, we provide end-of-line and performance evaluation test benches for, say, electrical motors, appliances like refrigerators and ACs and thrusters, etc. Our strength is our in-house expertise in automation, IT, chemical processes, and mechanical design. We leverage it to discover unmet customer needs and provide turnkey tailor-made solutions. Our solutions have helped clients to enhance their production and efficiency to achieve their sustainability goals. Our mission at Instron Technologies is to continuously innovate and enhance operations for customers globally in the manufacturing industry, process industry, and research laboratories. Our vision is to become a recognized leader in specialized products and solutions, particularly in process plant systems, digital factory solutions, and test bench systems. We aspire to make substantial contributions to enhance productivity and efficiency for our customers. We have been recognized as one of the 10 most promising industrial IoT solution providers. We are ISO certified, and we also got selected for DRDO Technology Development Fund and IDEX initiative. With this, we look forward to expand our presence in Canada, Australia, Sri Lanka, and Thailand. We have developed a young and dynamic core team and execution teams to help achieve the organizational goals. We strive to achieve the philosophy of growth at individual level and also at organization level. And because of this, we have leaders in our organization for day-to-day decisions.
I will continue. So we are talking about the why Instron Technologies is a reliable partner because of the key strengths which we are delivering in the industry, because of our cross-domain expertise and automation integration capabilities. We also support our customer relentlessly, and we have more than 200 industrial solutions implemented worldwide. The most important part is we have a strong network of value partner with a cross-domain expertise. This makes us a differentiator in the market. So going ahead with the next slide. So here we want to showcase our industry leading experience. So if you are able to see one of the few cases I am just briefing here. So some of the key completed projects that demonstrate our expertise and experience. We successfully completed a project for motor test benches designed to handle motor ranging from 0.12 kW to 15 kW with 3 test benches. You can see at the picture as well. These projects cover design, supply, installation, and commissioning of the system through integration with the mechanical beds. So achieving the correlation factor is the important part of the project. So we done it. Next portion is the retrofitting project, where there is handling motors from 37 kW to 355 kW with a 2 test bed with the selection of both auto and manual options. Though this project is revamped the system entirely and provides remarkable ROI. Okay. Lastly, we supplied and integrated control panels for motor test benches designed to handle motors from 125 kW to 315 kW with the 5 test beds. The most important part of this project is the completion of the project in a very short time. So these are the few successes which we are sharing here. But there are a lot to come in the coming slides where we will able to understand from our industry experts. They can showcase how our solution is helping our customers and taking their ROI in line, and we also provide the case study. So thanks for patience listening. Over to Milind.
Thank you, Dhananjay, for helping the users to understand the background of the organization and its credibility, especially into the motor test benches. So now I request all the participants and experts to switch on the camera for 1 minute. We would like to take a photo of all of you. So I just request all of you to please switch on your cameras for a minute. Grade B. Yeah. Can I request all of you to switch on your cameras just for a minute? Yes. Yeah, many faces coming up. Thank you. So we'll just take a screenshot so as to thank you for all of you to be present. And we are really sorry for those technical glitches in the volume and audio. Uh, right? So I request now all of you to turn off your cameras if you wish to. Otherwise, you can remain switched on. Thank you for listening to that request. Now, moving on to the next session, I would like to introduce our next speaker, Mr. Rahul Shirude. Rahul has completed his BE in Instrumentation and Control from Pune University. He comes with 15 plus years of experience working in India as well as North America in the field of test benches, automation, energy savings, and IoT. He is co-founder at Instron Technologies and heads motor test bench and automation teams. Now I request Rahul to take us all through state-of-the-art test bench systems. Over to you, Rahul.
Hello everyone. Thank you, Milind, for your kind introduction. So I'll start with the basics, what we do in test benches. So we ensure how the test benches are safe, quality and the reliability of and the product validation of the system. Test benches are mostly used for end-of-line and performance testing systems. We provide test bench systems for specialized equipments like motors, appliances, and thrusters. In these systems, we integrate the electrical, mechanical, and control systems to ensure smooth operations. All our test bench systems comply with the international standards and the certification requirements. In addition to the basic test benches, we incorporate these test benches with the IoT and the ERP systems. So we also, along with the integration with IoT and ERP, we also help in upgrading the existing test benches to meet with the latest industry standards and the requirements. Our main purpose of providing the test benches is to optimize the test operations, reduce energy consumption, and enhance the efficiency of the testing procedures. Let's talk about our one-stop turnkey solutions for electrical motor test benches. So we provide test bench systems for type test as well as routine test of the motors. In type test, we try to validate the design specifications of the systems, and in routine test, we try to cover the operational analysis of the systems. Our systems facilitate to provide comprehensive report generation, provide detailed analysis, and compare each motor's testing results with the design specifications to ensure quality. Test bench systems are compatible with both LT and ST types of induction motors, providing a wide range from 0.12 kilowatt to 355 kilowatt. We optimize the selection of test beds based on the motor sizes to be tested, ensuring precision, efficiency, and the cost effectiveness. Our system conforms to iASYS standards, guaranteeing reliability and compliance. We offer both selection modes, the auto and the manual, for flexibility in testing. Additionally, our advanced data acquisition systems provide real-time data logging and provide all the calculations for report generation, making it easier to analyze and validate the motors. We provide engineering design for the complete test benches, starting from understanding the requirements of the customers to evaluate their existing test bench systems and then provide them with a new or an upgraded option. We conduct a compatibility check to ensure seamless integration with the existing equipment such as variac, alternators, dynamometers, etc. Our detailed planning includes the preparation of electrical schematics, the bill of materials, and the sizing of the test benches. We carefully select all the drives and the AFEs for the size and the test of the motors, which provides precise control. The design of the test bench, range, and operator stations is tailored to meet specific requirements. Additionally, our systems generate all kinds of reports and data analytics to conform with the iASYS standards, and we also make custom reports to meet user-specific requirements. Our test bench platform provides a wide range of test procedures that includes load curve, full load test, rock rotor, no load test, in coupled and decoupled conditions, overcurrent test, dynamometer correction factors, temperature rise, hot resistance test. These rigorous procedures ensure that all aspects of motor performance are thoroughly evaluated, tested, and documented and validated with the design results. Our motor test bench offers comprehensive and user-friendly report generation, making it a standout solution in the industry for a one-stop solution. With just one click, you could generate reports and compare different sizes of motors. This system automatically logs data for master reports and generate reports in Excel, PDF, or sends data to any ERP systems as required. We could also provide remote monitoring of the systems for the third-party inspectors for the inspection of the motors. Our most significant USP is we collaborate with the design team of the end users and embed these calculations in our systems to achieve the expected correlation coefficient and validate the design at the R&D stage. This helps in fast tracking the new design of the motors. To conclude, our test benches are designed to meet all your testing needs, ensuring superior quality, safety, and reliability of your products. Thank you for joining us today. Over to you, Milind.
Thank you, Rahul. Now, moving on to the case study session, I would like to introduce our next speaker, Mr. Pawan Dugne. Pawan has completed his BE in Instrumentation and Control from Pune University. He comes with 8+ years of experience working in the field of automated test bench design and IoT systems. He has worked with MNCs like Rockwell Automation and has a working experience in North America. He heads the design and development team at the Instron Technologies. Over to you, Pawan.
Yes, thank you, sir, for the introduction. Welcome, everyone. Good morning. Thank you for joining our webinar for these motor test benches. I am really excited to share the one case study with all of you, where customer particular requirement was to test the motors of various ranges up to 355 kilowatts. So if we look at the specifications of the required motor test bench was extensive motor testing capability up to 300 kilowatt, and we need to incorporate all these various ranges up to 300 kilowatt in a test bench. Then compliance with IEC and iASYS standards. So we all agree that for this IEC and as far as these IEC and iASYS standards are concerned, it is very much required as far as customers' trust and reliability is dependent on it. So we need to comply the system for these IES and iASYS standards. Then we have requirement was diverse testing range as far as these various tests are concerned, as Rahul has enlisted earlier. So we have all these tested running in auto mode. That was a particular requirement. And yes, automated testing precision, that the precision and accuracy was requested around 0.1%. As far as the highest range like 355 kilowatt is concerned, we all agree that it might not be a big concern, but when we go to the 0.212 kilowatt for other customer, it becomes a concern. So we incorporated that successfully and we satisfied the requirement. So these were the specifications which were shared by the this particular renowned manufacturer of electrical induction motors. When we deep dive into that project, and we come to know that there are certain challenges. So if I want to take you through that challenges, the customer already had some legacy equipment present on the site as far as the old test bench setup is concerned. So this particular requirement was integrating the old system with new system and have a proper solution for diversified range. So that all the motors which manufacture on daily basis that can be tested in the real world applications, or we can duplicate the real world scenario to test the tests under the load and satisfy the requirement. So second challenge was enhanced precision and efficiency. So as we discussed earlier, that precision was requested around 0.1%, and as far as the RPMs for the motor for all kind of pole types were considered as a 2 RPM tolerance. So, and as far as efficiency is concerned, whatever operator manually was doing, the customer was expected that efficiency should be improved, and if we talking numbers, then from 5 motors they should be able to test the 7 to 8 motors or 10 motors. So that efficiency was requested. Then upgraded safety for high power motors, if we see the real time examples, or if we talk about real time examples, so we ourselves observe that safety is a very particular for in this kind of projects, because when operator was operating the motor station, we ourselves observed that in particular lock rotor type test, they have locked it mechanically, and it got shifted and motor started running. So these kind of safety factors we need to ensure that it will be more safer for the operator handling. Yeah. So these are the key challenges which we have faced and which we try to overcome and successfully overcome with the customer's help and internal team's help. If we talk about the project success factor, then whatever challenges we have faced or whatever requirements customers shared with us or conveyed with us, that unmatched precision in testing, we have achieved exceptional accuracy in motor performance tests. As it was mentioned that 2 RPM tolerance was accepted, but yes, we have achieved the exact same matching of RPM or 1 RPM tolerance sometimes. And it is the same in all factors. If we consider power, torque, frequency, input power, output power, and the calculated power with the help of resistance temperature calculations. Then we have ensured that efficiency of the motor test bench should be improved. The time required for testing, if we talk about the real time world example, that what we have observed on site. So test setup for any kind of motor was required around 10 to 15 minutes to set up everything, to get started with the test, and wait until the motor goes to kind of an equilibrium state, so that we can start capturing data for the analysis. But when we successfully completed this commissioning and hand over the plant, so the condition was the equilibrium state was we successfully achieved equilibrium state within 2.5 or 3 minutes, so that 10 to 12 minutes of the setup and equilibrium waiting for equilibrium state has been improved. And enhanced safety protocols, yes, we have enhanced the safety protocols for the user. Like one example I had discussed earlier, that for that particular lock motor, or we can take another example of auto transformer. So whenever there is a power off cycle, so when power goes off and power come back, that auto transformer is already set to some particular voltage, but that safety protocols was never there before, earlier in the earlier test bench from the customer. So we took, like, this is a one example. There are a particular number of interlocks or safety measures, we can say. We have taken care of that, and the mechanical lock of the lock test motor, that also we have tried it with the electrical lock from the dynamometer itself. So there were no mechanical rods or something like that in the picture when this test and operator safety is concerned. So yeah, these were the challenges, and these are the project success factors which we have successfully satisfied our customer. If we talk about benefits, yeah, whatever challenges and these success factor we have discussed, we try to accumulate this in the table. So the test bench configuration, it was a single panel and a limited testing scope earlier because it was nothing was automated, everything was manual. But after implementation, it was a single panel and dual test bench setup, and it also increases the range of the motors and flexibility for the testing. Capital expenditure and productivity, yeah, the higher operational cost has been reduced. So if we say in a way that number of motors, they can test more motors in a day, so that kind of capital expenditure and ROI has taken care of. Report generation, particularly for report generation, like if we see that load curve calculations and coefficient correlation coefficient, these calculations, it was a like tough job earlier for the operator. But when we came in and we captured the exact data from the equilibrium state of the motor, so it was the like a hassle-free operation for operator, so that he'll be more focusing on analyzing the data instead of doing the documentation manually. Then error rate and accuracy, yeah, we all agree that there might be some manual errors while taking the data while test is running. So we try to capture only data from the equilibrium state and not before or after that. So we successfully achieved that state and lock the correct data. Then test time per motor, the setup time and waiting for equilibrium state has been reduced measurably. So that test time per motor has reduced sufficiently, so that number of motors can be tested per day can be increased. Safety measures we already discussed. There I discussed about the electrical lock and auto transformer. There are other safety measures also. We have taken care of that. And yes, remote monitoring and reporting point of view, Rahul already discussed that these communication with the existing SAP or ERP, that data can be available on that particular customer server with the help of only one unique ID as far as each motor is concerned. So yes, thank you everyone for joining.
Yeah. Thank you, Rahul and Pawan, for helping the users understand the types and specifications of the motors, test benches, and how your organization has helped customers through relevant case studies. Now, the most interesting part of this webinar is the test benches for advanced motors powering the electrical vehicles. Our next speaker comes from iASYS Technology Solutions Private Limited, Pune. For more than 25 years, iASYS has been serving the automotive industry with a strong record of over 550 plus systems installations covering engine, vehicle and component testing and automation systems worldwide, leveraging innovations in the system integration, data and facility management, EV and fuel cell electrolyzer testing technologies. iASYS is driven product which are used in the product validation and verification process of the complex engineered products. I would like to introduce our esteemed speaker, Mr. Rutuj Undale, Senior Engineer iASYS. Rutuj holds a master's degree in automotive engineering from Coventry University, UK. As a senior engineer at iASYS Technology Solutions, he specializes in developing advanced EV technology solutions, including motor, powertrain, and vehicle testings. With expertise in transmission, e-axle, battery, and motor emulators. Additionally, he is well versed with the European and global emission standards, which effectively integrating regulatory compliances into automotive testing protocols. Over to you, Rutuj.
Thank you so much, Milind sir, for this kind and generous introduction. regarding iASYS technologies and also regarding, so we'll start with the motor testing webinar. So in the previous slides, with the previous speakers, we have seen how the induction motor testing takes place. So in this further slides, we'll see how the motors which are used in the EV vehicles are being tested and what is the purpose, what are the test cycles, and everything we can discuss in the further slides. To start with this, we need to see what are the types of EV motors we used in the particular EV industries. So starting from the permanent magnet synchronous motor, which is a PMSM motor, as it specifies, it is a very high efficient and a high power density motors, majorly which is being used in the passenger vehicles, commercial vehicles, heavy commercial vehicles, which gives very high efficiency and high speed torque curve, which allows vehicle manufacturer to prefer this type of motor, which is a PMSM motor. So another one is the brushless direct current motor, which is a BLDC motor. The standard characteristics of this current motor includes the high torque at low speed, which enables to the manufacturer to use these motors in two-wheeler applications majorly. So you can see the second image where the wheel is mounted or the motor is directly mounted on the hub of the wheel. So that's why it's called a hub motor as well. The next one is the induction motor. So we have studied or we have seen this induction motor intro in the previous slides also. So the main application or the main one is the high reliability, simple maintenance, and the measure will be the low cost. So the cost application of the implications is very low in the induction motor. So that's why it has been preferred by some three-wheeler manufacturers and low commercial vehicles manufacturers. Next one is the SRM motors, which are a switched reluctance motor. The characteristics enables the high torque component with the effective torque and speed characteristics. So these kind of motors are being used in the the applications where the high torque has been implied. So you can say in the two-wheeler sections and also the passenger car vehicles. Let's see some comparison between the characteristics of different types of motor. So right from the power density, efficiency, controllability, reliability, and technological maturity, we can see the PMSM motor acquires a very high and very efficient way to do in this. So that's why the major vehicle manufacturer goes for PMSM motors due to this very efficient and the hold on its characteristics in the various parameters. But also due to this cost implications, many of the customers go to the BLDC or induction motors depending upon the application of the vehicles or which audience or which target customers they are looking for. So the benefits of motor testing. So the first one will be the ensure the proper performance on the speed and torque to validate the design of the EV motor. So in this, majorly the manufacturer sees whatever the motor which has been designed, the performance and the speed torque characteristics to check the proper insurance. These tests are being taken on the performance base and the torque and speed basis. Next one is the complete efficiency check as per the requirement from the mechanical and the electrical point of view. The durability testing, which supports the validation, also has to see the robustness and the durability of the motors in the shortest time. So we have to see how the durability is there during the testing or how the motor performs in the long run. So the durability testing comes in part or comes in the picture in this. To conduct the various drive cycle tests on the motor level to ensure the vehicle testing will be happening on the motor level. So many times the vehicle customer or the vehicle manufacturer has to ensure whatever the vehicle performance they get on the wheel level or at the road level, they have to do on the motor level itself. So we have initiated or we have developed another product which is a road load simulation, which enables to do this drive cycle test or vehicle level test on the motor level itself. identifying the potential issues and allowing the proactive maintenance to prevent the breakdown and extend the motor's lifespan. So conducting these types of tests on the motor level ensures us to prevent the breakdowns and also increase the efficiency during the application of these motors. The testing reveals the opportunity to improve the performance by assessing the characteristics like speed and the energy consumptions. Testing collects all the data to inform the efforts to create the more advanced motor technology. So getting the data from all these test cycles ensures the designer as well as the manufacturer to make more advanced motors depending upon the previous data and whatever backlogs they have been created. So we can ensure the safe and very good and robust future in this future technologies. Now let's see the basic architecture of the motor testing lab or the motor test bench. So as you can see, yeah, sorry for the glitch. So as you can see in the PPT, this is a simple components or the simple architecture of the motor testing assembly, where you can see the major components. We can go one by one. The first one on the right corner is the dyno, which is the dynamometer. It is used to load the vehicle motor or the testing motor to check the performance of the system. Okay, so to drive that dyno, we need a drive panel, which is a VFD, which is a variable frequency drive. So that is another major component in this complete entire system. So apart from that, to power the vehicle motor, we have to use some a battery or a power supply, which is being used in this setup called a DC power supply. So which acts as a battery to give the power to the motor. Apart from that, to measure your electrical characteristics, we have a electrical sensor known as a power analyzer, which is being used. So depending upon the motor type, we can use various number of channels, starting from your 3-channel, 4-channel, up to 8 and 16 channels power analyzer with the help of current sensors. So to measure some of this entire system, we have to have a proper control system to control this complete architecture. So the main brain of the system comes in the automation panel and the control system, which I guess iASYS has the main USP in this portfolio. So creating the test cycles, completing the drive cycles, and also the report generation with the various transient test cycles, which ensures the high reliability of the motor testing. So this was the basic architecture. So these are some pictures to give some idea about the major components. Right from the first photo, you can see of the power analyzer, which is a 8-channel power analyzer or a 4-channel. So depending upon your motor type, these devices can be selected. So other one is the DC supply, which gives your current and voltage to your EV motor. So to check the whatever voltage, current, and electrical parameters are there, we have current sensors where there are 2 types of current sensors you can see. The first one is the pass-through current sensor and another is the clamp. So depending upon the application and your requirement, we can select whatever sensors you require. The next one is the thermal chamber. This actually it is an optional one for the manufacturer. So if the motor manufacturer want to test their motors in certain humidity levels or certain temperature levels, this chamber can be used just for the motor itself. So the another part is the torque sensor, which is a critical part of this complete entire system, because until and until you get the torque and the speed of the system, you cannot ensure the performance of that complete test system. So the torque sensor is another important part, and the next one is the dynamometer, which is the load system. So this ensures the loading system to the EV motors, where we perform the transient test cycles depending upon whatever inputs we have given. Coming up to the next slide is the test automation and the data acquisition system. So rightly, as I said before, it is known as the brain of the system. So Orbit EV control system, which is a iASYS developed platform, is being used to control these test types. So you can see as it is a flexible platform. So there are n number of devices used in this complete test architecture. So to see the test data or the devices data, we have to integrate those devices with the test system. So our platform ensures the flexible integrity with all the devices and hardware equipments to see those data which are ensured during the testing. The test cycle which we take on the test data or the automation system gives you the entire, you can say, the 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 test data where you can see the graph on the side, which is the RLS test, you can say. So to control and to perform this test cycle, we need to program it according to the requirement of the speed and torque. So including the speed and torque, we can generate any type of test cycle during the testing. So once the test cycle is conducted, the report can be generated in any required format as per the customer's requirement, which ensures whatever testing you have taken, is it on the mark or whatever requirement you have, it's up to that or not. So the next part is the road load simulation and motor level. This plays a very vital role on the vehicle manufacturer and the motor level manufacturer because it ensures the vehicle data or the vehicle level testing on your motor level, where we can take the vehicle level test cycles such as IDC, WMTC, and other duty cycles on the motor level depending on the vehicle parameters. So these are some test types and test standards from where we can go through that. The first is the measurement of total loss and total efficiency. The main standard the ISO has been revealed is ISO 21782/22019. So this standard ensures the complete testing and complete efficiency of the measurement. So this standard includes all these tests with the complete test procedures, whatever report generation format is there. So we can refer to that standard for this all testing test cycles. So there we can have a temperature rise test, torque characteristics, high acceleration deceleration test, maximum torque endurance test, and overspeed test. So iASYS actually have developed a containerized test solution. So where you can have a complete entire test system in a single container. So you can see a dynamometer, induction motor, controller, and the control room with the automation system has been developed entirely in-house. So these actually systems are available on the rental basis as well. Because if you see on the startup culture, not many startup companies are being there to invest such a huge amount in this test bench. So we offer whatever entire solution what we have in-house to them to check whether the performance of their motor is as to the good or not. So just it's an initial one step you can say to help these ecosystem and the EV testing solution startup companies. So talking about the iASYS, like the major strength is our wide 25 years of experience in this complete entire ecosystem, which gives us very high customer centric deficiency and also the highly customer centric, which gives the control over the test systems. The solution-based approach, depending upon the product and the project, where the customer faces the challenge, and we are there to approach with whatever solutions might be a customized, might be a standard solution. As this is always there to help to work with the customer as their partner itself. So major competencies in-house is the engineering, in which we have the mechatronics department, a separate electrical, and a mechanical design. So in the integration, the test automation, real-time control, embedded, and the communication of the devices. From the engineering, we have our own software team which develops our own software platform and also the products. That's it from my side. Thank you.
Yeah, thank you, Ritush, for sharing your practical experience with EV motors, test benches, different compliance standards and benefits that customers can realize. I'm sure you, as the users, can understand the actual world implementations of such systems. Now, having come to the end of our first section in which our experts have shared their insights, especially on what are the types of tests, what is the need of such test benches, the testing standards for both induction as well as the EV motors, special types of sensors and systems, and what are the capabilities of these two teams, Instron Technologies and iASYS Technology Solutions, in the subject matter. So I think the users have got sufficient takeaways and learnings from this knowledge sharing webinar. Now, I also would like to, I'm reminded by my admin that the LinkedIn profile has been shared into the chat. So if you want to connect with the users for any further follow-up queries, then we can definitely have a reference from that LinkedIn profile. Also, another reminder from the admin team is for submitting your responses and feedback for form posted on the chat box. This is especially for the members who have joined directly without the registrations. We request you to drop your contact details because we are going to share some follow-up emails or the recordings so that you can use it for your further follow-ups. Now, with this, let's move on to the next section of the webinar in which, having heard from all the experts, now you want to ask few questions to the experts. Till the time you all make your questions ready, I'll ask the questions received in the chat box. So I think the first question that we can ask is, and it can be directed to Rituj. The question is how the vehicle level test can be performed on the motor level. Rituj, can you share your thoughts on that?
Yeah, sure. I guess we have got one question from the user, like how we can take the vehicle level test on the motor level. So to give this some clarification on that, like we have some vehicle parameters in this, such as some aerodynamic drag, ABC values, curb weight, or the vehicle weight. So depending upon these few vehicle parameters, we have a drive cycle also, which is in the kmph versus speed, or speed versus time, you can say. So to take those vehicle level tests, we have to first ensure we could transfer those kmph or speed versus time cycles into speed and torque. So to transfer that, we need some vehicle parameters, as I said before, the ABC values, the curb weight, and the radius. So that ensures us to do this transfer, and we can get a test cycle in speed versus torque. By this way, like we can convert this IDC, WMTC test cycles into speed and torque, and that can be directly tested on the motor level. In one of the application of the customers, like we are right now testing in one of the customer, the range level testing, or the range of the vehicle can be taken itself on the motor level. So that type of development in the motor testing we have gone up to. Yes, so that's how we can take the vehicle level test on the motor levels.
Yeah, thank you, Rituj. That really helps our users to understand this question. Now, I think there is one more question in the chat box, which is how to lock a rotor electrically in a rotor lock test. I think this question can be answered by Pawan. Pawan, can you please share your thoughts on this?
Yes. So how to lock a rotor electrically in lock rotor test, right? So when we are talking about the motor under test, we have a dynamometer for the loading and other purposes. So as far as electrical locking of the motor under test shaft is concerned, we can simply Okay, we can simply give dynamometer a command that it should not rotate, or it should rotate at 0 RPM. So it will not allow motor to run further, motor shaft not to run further, and it will hold it to 0 RPM even if we give the supply to the motor. So yeah, that is the answer for that question. That in that manner we can lock the motor shaft electrically. So there will be no mechanical arrangements are included.
Thank you, Pawan. Yeah. Now the next question is from Rohit Purohit. Rohit Purohit, sir, can you please unmute yourself and ask your question?
Yes, hello. Hello, everyone. I represent Rotomotive Power Drives India Limited. We are based out at Anand, and we make motors from last 30 years, but from last 5 years we are into EV motors. And I have got two specific questions, maybe directly to Mr. Rutuj. One of the questions is that we totally design the motor in-house, we manufacture it, and once we are ready, there are two big companies like ICAT and ARAI, and the certifications over there are costly. So, is it possible to test the motor as per the AIS standards, what are mentioned in this ARAI and ICAT, so that the test will not fail over there?
Yeah, Rutuj, yeah.
Yes, definitely, sir. As you mentioned, like whatever test cycles and the testing you do at ARA or ICAT, we do the similar type of testing. So we actually help you to take those tests, or to have a exact feel what you can test over the ARA and ICAT. So it's better to test over here to take and to ensure whatever test results you get, whether it is in the limits as per your standards or not. So all the standards, whatever you have mentioned, let it be AIS or ISO, whatever standards, we can perform all the test standard tests on these motors, and we can get the data. So you can, before going to ARAI, you can ensure your test results, and directly you can go over there.
Okay,
Yeah.
right.
Thank you.
One last question. Another thing, that we develop any motor based on the requirement of customers. Now, customers of e-vehicles may be not knowing what torque they require and what speed they require in terms of RPM. They just give us the requirement of KW, means their gross vehicle weight, and their kmph, and that is their speed. So, is there any simulation or is there any pattern where we can test any motor that can directly relate to gross vehicle weight of that vehicle?
Yes, definitely. So if you see in the AIS standards, depending upon the vehicle weight, we have the ABC values of the vehicles. So we can use those ABC values, and we can transfer this kmph data into speed and torque. So in that way, we can directly test your vehicle standards onto the motor level. So that will be helpful for the customer as well as to you to develop the motors.
Now we have one next question from Suresh, sir. Can you provide the test bench for industrial gearbox testing? I think Rahul can answer that question.
Yes, we could provide that, sir. We could have a motor and a gearbox which we could switch on and you could use it. So we could definitely provide that test bench. We could get in the details and we could do that.
Right. Yeah. So once we get the details, I think then we can provide the further details on the types of and specifications of the test benches. Right. I think there is next question from Saurav sir again. Saurav sir, do you have a test bench for small BLDC motors for water pump, fuel pump, HVAC blower motor, cooling fan? The motor sizes are different. Outer shaft dimensions are also small. So I think this question can be answered by, the motor power is 12 volt, 50 watt to 1 kilowatt. So I think, yeah, I'll just ask Rahul to answer this question. Yeah, Rahul.
Yes, sir. Yes, definitely we could provide you with that range of motors and the specific applications, a test bench. We need to have more details about it and the accuracy level that you require or any specific standards you want to comply with, and then we could come up with a solution for that.
Okay. Great. Thanks. So the next question is, what is cogging torque and how to check on the test bench? I request Rutuj to answer that question. Yeah.
Yes. So basically, the cogging torque is nothing but the initial torque before your motor gets started. So it's nothing but similar to the block rotor test, where a very sensitive torque sensor is required to check the torque of the motor during the initial test conditions. So when the motor is starting, you get some sensors from the torque. So by that, we can check the cogging torque of the motor.
Thanks. Thanks, Rutuj. Yeah, I think there is one more question in the chat box. Why the regenerative loading arrangement is required in the motor test benches? I think I'll ask Rahul to share that. Yeah, Rahul.
Yeah, a very interesting question. It generally comes in all applications. The type test generally operates for a duration of 4 to 6 hours. To overcome the increase in the cost consumptions for testing, we recommend regenerative loading arrangement that facilitate to feed back the power for the testing purpose, reducing the operational cost of testing by approximate 80%. This also helps to fine-tune the loading arrangement and the accuracy of the testing. And it also supports our initiatives for environmentally friendly test benches. Thank you.
Yeah, I think that answers the question. Is there any question that the users want to ask? You can unmute yourself and ask those questions, sir. Yeah, I think there is one more question in the chat box. What is crawling torque and how can we measure? I think it is already answered. Yeah. Okay. I think the question was already answered. We'll be sending the recorded video of this so you can understand that. I think there is one more question. Can the time response in milliseconds observed during vehicle level testing be achieved using a dynamometer? Yeah, Rutuj?
Yeah. So during the vehicle testing, the major part we have to see is the inertia simulation, which occurs on the vehicle level testing. But when it is transferred to the motor level testing, the controlling at the millisecond level is more important. So what we have observed with our own automation system and the control system, we have been controlling this testing in 10 milliseconds. So that's the time what we have observed, the time response.
I think there is one more question. Is there any ready Excel sheet or spreadsheet for speed torque with pre-defined vehicle parameters? I think yes, it is there. And if you share your email details or you can contact us on this contact details, then we'll share with you all these details. So is there any question? We have a few more minutes to.
Hello, I have one question.
Yes, please.
Do you develop?
Can you tell your name first so that we know?
This is Prashant from CG Power Goa. I have joined along with Karthik Sheladia.
Great.
So mainly we are manufacturing single phase motors over here in our Goa plant. So have you developed any single phase motor test bed fast for some customers?
Yes. What was the range, sir? And we have developed single phase motor test bench as well.
Okay, it is 0.12 kilowatt to around 5.5 kilowatt.
Okay. Yeah. So that's a range. Yeah, we could do that. Any specific requirements you have for that?
No, because we are facing some challenges in measurement of pull-up torque and pull-out torque. Because it mainly pull-up torque is mainly depends on the opening and closing of the overcurrent switch, which is mainly installed in single-phase motors, right? So that is the main difference between single-phase induction and three-phase induction motors, right? So it is very critical to this thing measure this run-up torque or pull-up torque. So that was my question actually. So have you faced any challenges during the measurement of this type of torques or not?
So in one of the requirements, in one of the applications that we have provided, this pull-up torque and pull-up torque was not required. So that was the reason we did not. But for three-phase, we have already been doing it. So we could also study a requirement and we could see what we could do with the existing options we have.
Yeah. Okay. I will mail you our requirement.
Sure. Okay.
Thank you.
Thank you.
I think we are getting lots of questions. So I'll ask a couple of few questions. I think it's really interesting to see so many questions. Is a battery setup required for DC motor testing? Yeah, Ritush?
Yes. So as it says, like it's a DC motor, it requires actually two phase. So using the DC supply, we can directly give the power to your DC motor. So in that case, to ensure the complete wide range of testing, you require the DC supply, not the battery.
Thanks, Ritush. I think there is one basic question which is like, is this webinar available on recording? Yes, I think yes, it is available. As told to all of you, those who have joined after registration, we have their email IDs. Those who have joined directly, we request them to send their email IDs in the chat box so that we will share this recording and follow-up material with all of you. So that's a sincere request. Yes, it will be available on the YouTube as well. There is one more question. How do you collect data for the test results? What volume of data you keep? Do you have any cases where historic data is used to form a test simulation? Yeah.
Yes. So actually, in the previous test schedules, what we have observed, like during the durability testing, we have taken the test for continuous 200 hours and 400 hours. So in that case, whatever our automation is capable to keep all those data intact, and that can be directly used to form a test simulation as well.
Thanks, Ritush. Are there any questions that the users want to ask? Yeah. Okay, I'll ask one more question received from Kedar. Can you support noise emission testing of motor? Yeah, Ritush?
Yes, actually, particular test we required some particular devices related to NVH and the EMI EMC. So with the help of that device, we can use or we can do that motor testing.
Right. Thanks, Ritush. Yeah, I could hear one of the attendees wanted to ask a question. You can unmute yourself and ask questions if there are any. Great. So with this, I think we bring this webinar to the conclusion. Thank you, speakers, for sharing the knowledge on the test benches. Thank you, participants, for making this session so interesting, especially the last couple of minutes in which we could get the actual questions, and those were not the chatbots for your information. So yes, it was a nice discussion, follow-up discussion. We will get in with you. Thank you, organizing team led by Sneha for having the flawless session. Sneha will contact you for any further queries and follow-up meetings. With this, we'll come back to you with our next webinar soon. So we thank you once again to all of you and have a great day ahead. We look forward to coming back on this series in the next quarter. So thank you once again. Looking forward to meet all of you.